Hi everyone, is my audio audible to all?
Yes, sir.
Okay, so let's wait for some time that remaining students to join. Is my audio and video is it clear?
Yes, sir.
It's okay. So I'm going to start the class. Is another yet to come? So CRs, please unmute your mics. Let me know the update to what you are having at your side. Only CR and LR. Okay, hi students. Good morning all. So today we are going to discuss about how the power is generated in a nuclear power plant. Okay, so this is how the layout of an nuclear power plant is. Okay, is my audio audible to all? Please respond. Okay, Okay. Okay. So this is the layout diagram of an nuclear power plant. Okay. First, let's try to discuss about how the nuclear power plant fusion reaction is taking place and how the different components are assembled. Okay. So first one is nothing but in a nuclear power plant, the energy is generated by a process called as nuclear fission process. Okay, so now we need to understand how the energy is generated by nuclear fission process. In this nuclear fission process, we are going to have the heavy elements like uranium 235 as well as thorium. So these are nothing but the heavy materials that are used in an nuclear reactor. So coming to the reaction, so we have the heavy element uranium 235. It is undergoing with an slowly moving neutron, and it undergoes bombardment to give an output as Ba, which is nothing but the Latin name is Ba, and it is called as barium 141, and it is going to give the krypton. So Kr is nothing but krypton with a weight of 92, and it is going to give three neutral atoms, and it is going to generate the energy. Okay. So now we need to understand what is meant by this neutral atom. Okay, so here this neutral atom is characterized with this is slow moving. So it is trying. It will be generally moving very slow, and this neutron will be continuously hits. I mean, it hits repeatedly or continuously to the uranium to give an output as a barium as well as krypton. And once again, this neutron will try to combine with available the nucleus of the heavy material, and ultimately an energy where in the form of heat energy is generated. Okay, so this is what actually the working of an nuclear power plant, and this is the chemical equation governing how the nucleus is undergoing bombardment, and it is going to split as barium as well as krypton and three extra neutrons, and energy is generated. So fission process is nothing but the way you split up. Okay, so the way the nuclear elements are getting splitting is called as nuclear fission. But there is one more process which is called nuclear fusion. So nuclear fusion process is also similar, but here we are going to combine the heavy atoms. So this is all about nuclear fission as well as nuclear fusion. So in this chemical reaction, a lot of energy is generated. Okay, so now let's try to understand what's really happening. Okay, so for 1 kg of uranium, if you are using, okay, so you're taking 1 kg of heavy material of uranium, so that is going to produce an heat equivalent to 4500 tons of high grade coal. So we are going to use 4500 tons of high grade coal, and we are going to use an equivalent amount of 1 kg of uranium. Okay, so here the heat produced by the uranium is equal to the heat produced by the coal plant by using 4500 tons. That's why these nuclear power plants are very powerful than compared to any other. Okay, so now let us try to see here what are the different components we are going to have. So here, let us if you observe the diagram. So here, this is called a nuclear reactor, and this is called moderator, and this is called fuel rods, and this is called control rods, and all these the generated heat will be sent to the heat exchanger and the steam will combine. So this is called as the loop. So this is nothing but called as the loop 1. Okay, so sorry, this is called as loop 1, and this is called as loop 2, and this is called as loop 3. So there are three loops in this nuclear power plant. Now let us try to discuss one plant by another. Okay, so hope everyone has joined the meeting. So here it figures out and 18 has been joined. Shall I continue? Is it audible to all? Just respond. Just you can speak out. So, Sias, please unmute your mic and just give the response. Is it audible? Pavan, unmute your mic. Is it audible? Video? Are you able to see the nuclear power plant? Okay. Shall I wait or the remaining will come and join later? Okay. Shall I continue the class? Okay. So I have not given any official permission. You can join continuously as per your availability. Okay. So I had removed all the required permission. You can continuously join, so it will not disturb our class. Okay, Pawan, shall I continue? Okay. So if you have any issue, please let me ping me in this chat box such a way that I can understand is any mistake with audio or video. Okay. All right. So these are the different parts we are going to have. Now let's try to discuss about what each part is going to do. So this is called as the layout diagram of an nuclear power plant. So let's try to see the layout diagram in detail. So this is the original layout diagram how we have in the plant. So here you can see here. So this is nothing but the nuclear reactor. So let's try to discuss about each individual part. Okay. So first one is the fuel rods. So what is this fuel rods? So fuel rods are nothing but they are made up of uranium 235. Okay, so the fuel rods will be made like an pellet, like in small types of carrot. When you cut your carrot, it seems to be like an pellet. So uranium is also made like this, and this uranium is kept in this fuel rods. And the reactor consists of fuel rod. I mean, this complete reactor consists of fuel rods, moderator, as well as the control rods. Okay, so now coming to the control rods, what this control rod will do. Okay, so control rod. So control rod is made up of cadmium. Okay, so this is made up of an element called cadmium, and already we had seen in the equation three extra electrons has been generated. So here you can see in this equation three neutrons. three neutrons has been generated, those will be absorbed by our control rod. So this control rod is made up of cadmium, and the purpose of this control rod is to absorb the extra neutrons that are generated. So this control, the name itself says that this rod is used to control the reaction of the nuclear power plant. Therefore, this control rod can be inserted into our nuclear reactor, or it can be removed. Okay, so you can move this control rod to inside, or you can move your control rod to outside. So if you insert this control rod inside like this, if you insert it, so it is going to absorb the extra neutrons, and it is going to control the action of the nuclear fuel. If unable to control, it may lead to explosion. That is the main problem we have. Okay, so we can move this control rod inside, or you can move our control rod outside. That's what this control rod is going to do, and the purpose of this control rod is to control the nuclear fusion reaction. Okay, so these are the three purpose of this control rod. Now, coming to the moderator. So already we discussed about the fuel rod. Fuel rod is made up of uranium of pellets, and control rod is made up of cadmium. And we can move this up and down to control the reaction rate or the chain reaction. And now we are going to have the moderator. Let's try to see what is the function of this moderator. This moderator is made up of graphite rods. It's nothing but carbon. Okay, so this is made up of graphite rods, and this moderator is generally used as an a coolant liquid. Okay, and what is the purpose of this moderator? Is this similar to that of an control rod? It is used to slow down. Okay, so neutrons will be moving with higher speed, so we can slow down the speed of these neutrons. We can slow down the speed of the neutrons, so before they bombard to the neutron. Okay, so here I already told. So whenever this neutron has to be slowed down before it bombards, or whenever it is going to hit rapidly. So what is bombardment means? Bombardment. So we need to understand the meaning of bombardment, which is very important. Okay, so the meaning of bombardment is nothing but hitting continuously is called as a bombardment. So when you hit it continuously, okay, hit repeatedly, then it is called as the bombardment of the neutron. So in order to reduce its speed and to continuously bombard, so this is how the energy is like an high amount of energy will be released. So that can be controlled with the help of a control rod. So the moderator work is to slow down the speed of the neutron before it bombard the fuel rods. Okay, before they are going to hit the fuel rods, so the speed of the neutron is controlled or regulated with the help of an the moderator. So this is the function of an moderator. Okay, so this nuclear reaction is like an chain reaction, and continuously it will be used, continuously hit the uranium, and continuously energy will be generated. Now let us try to discuss about what are the different types of reactors we have. Okay, so let's try to discuss about the reactors. So we are having two types of reactors, which is nothing but pressurized water reactor. So pressurized water reactor. So in shortcut, it is named as PWR. Okay, so these are called pressurized water reactor. Here, water itself is the coolant. So the heat energy which is generated, we need to cool this. We need to convert this heat energy to an steam with the help of heat exchanger that we'll discuss again. So let's try to discuss about the parts first, and later on we'll go into the how the action will be taking place. Okay, so the reactor is nothing but a pressurized water reactor, and water will be available within the reactor itself, and it will be trying to move in this loop one. Okay, so the pressurized water reactor, so here water itself is acting like an coolant, and this water is called as the moderator of this plant. Okay, so Here water we are going to keep at a very high pressure. Okay, so this water, what we have as the coolant or moderator, it is kept at high pressure. So the pressure of the water is high. If the pressure is high, so such a way that water do not boil. So water will not boil. Okay. So when you're maintaining with high pressure, the heated water. So now this heated water, what we have been heated in our reactor will be pumped into heat exchanger. In this heat exchanger, the total heat energy from the reactor will be circulated in these pipes, and automatically the total water which is there in this heat exchanger will be converted into steam, and the steam is going to run our steam turbine, and the left water of the draft will try to go into condenser, and this condenser is going to cool, and it's getting circulated again into our steam exchanger. The purpose of this steam exchanger is to convert the heat energy from the coolant into an steam. That's the purpose of this heat exchanger. Okay, so the heated water is transferred through the heat exchanger. Now here you are going to have the water with more amount of heat, or this is called water as the coolant. So here we are using our water as our coolant. So the advantage of this one is, the radioactive material which gets circulated will be observed only in this heat exchanger, and the water. So this is nothing but the first loop, and this is nothing but the loop two. In loop two, we are not going to have any radioactive materials. Okay, so here in loop 2 we don't have any radioactive material. Okay, so this is how we are going to provide the safety. Okay, so this radioactive material is basically very dangerous in nature, so that's why it should not react with the turbine, and it may create some a lot of health hazards. So that's why in this pwr, the secondary loop is free from radioactive material, and here is how this PWR will act. This is nothing but water itself will act as an reactor. And next one is boiling water reactor. Okay, so in this boiling water reactor, let's try to discuss about the next reactor. So which is nothing but a boiling water reactor. So which is called BWR. So here there's no need of heat exchange. Okay, so here the only one loop we are going to use. Okay, so here we will remove this heat exchanger. So the heat exchanger will be removed, and whatever the water is getting heated will be directly available to the turbine, and there's no need of an heat exchanger in the case of an boiling water reactor. Okay, so here what we are going to do is, in this reactor water is allowed to boil. Okay, so we have the water, and this water is allowed to boil continuously. Okay, so whenever the water is getting boiled, automatically this water will be converted into steam, and the same steam will goes to the steam turbine, and the steam turbine will try to run our alternator. So this is nothing but rotor of our alternator, and this is nothing but a stator of our alternator, and this stator is made up of field winding. So already we discussed in the class, and the stator is made up of armature winding. So therefore the EMF which is generated, which is nothing but a three phase 415 volts 50 hertz supply is generated. Okay, and coming to here, what are the disadvantage of this plant? Okay, so here the water will directly reach the turbine. I mean, the radioactive material from the fuel rods and the moderator and control will directly reach the turbine, and the turbine will be having the radioactive effect. Okay, so that's the main problem with this moderator. Let's try to have a small revision, very simple. So what are the parts we have is a reactor, moderator, fuel rods, as well as control rods. Okay, so all this reactor is used to complete the nuclear fission reaction. And what is the heat produced? And here the heat produced, it will be kept in the water, and here the water is used as an coolant, and the water will circulate in this heat exchanger, and all the heat which is generated will be converted into steam, and it's going to run our steam turbine. And the output of the steam, here it is their steam, so it is trying to cool down with the help of an condenser, and automatically the condensed water, I mean the which the vapor, I mean the steam is converted into water at this level, and it's try to make our turbine to rotate continuously, and water is also made like a loop, and it continuously rotates. Okay, and here this is sent to the cooling tower. Now let's try to discuss about the heat exchanger. What is the purpose of the heat exchanger? So the purpose of an heat exchanger is it transfers the heat to the secondary loop. Okay, already we had seen in the diagram. So it is used to transfer the heat from this water into the steam turbine. Okay, this is a function of a heat exchanger. It transfers the heat to our turbine, the form of steam. So water from the second loop is converted into steam, and the purpose of this heat exchanger is it protects the radioactive material mixing up with the turbine. That's how it acts like an separator. So this will act as an loop 1, this will act as an loop 2. And after that, very simple, coming to the steam turbine. What is the purpose of steam turbine? So already we told that. So steam turbine is nothing but we have the blades like this, and whenever our steam is going to heat, and the central part is connected to our rotor of an alternator, and we are going to, so this is nothing but the rotor of the alternator, and this is nothing but the stator of our alternator. The stator of our alternator is made up of armature winding, and the rotor is made up of the field winding. Therefore, the generated EMF will be available as RYB, which is nothing but a three-phase 415 volts supply. So that's how this steam turbine will convert the. So the purpose of the steam turbine is to convert the mechanical energy into electrical energy in terms of voltage. So here what happens in this steam turbine is whenever the steam hits our turbine blades, the pressure of the steam will reduce. So the pressure reduce and the volume of the steam will increase. As the volume of the steam increases and pressure decreases, the steam turbine is effective, I mean the steam turbine will continue to rotate, and automatically it will rotate our the rotor part of our alternator. Therefore the EMF will be generated in our stator. So this is all about the heat exchanger, how heat is exchanged, and how this turbine will create an low pressure and high volume and make our turbine to rotate, and ultimately rotates our alternator. And coming to the condenser part. So what is this condenser? The steam output of the turbine is, so the condenser, we are going to have the steam output from the turbine. The steam output will be again converted into water with the help of cooling towers, that is called condenser. Okay. So the purpose of the condenser, this converts the vapor from the steam into liquid. The steam is cooled through an, so this is nothing but that's what I'm saying. So this loop will help us to cool the water. Okay, so this is connected to the cooling tower and it gets cooled off. Now we are going to have the condenser water loop. So this loop is called loop 3. That's how the water gets cooled off. Okay, so this is how the physically and turbine is there. I mean, how this nuclear turbine will, I mean, nuclear power plant will work. Now let's try to see some images which will create a lot of clarity. So here you can see the structure of an nuclear power plant. So this is our nuclear power plant. So this is called reactor, and here you are going to have the control rods, and it is having a lot of pressure, which is water is used as an coolant, and the water gets circulated to this where this is called as the heat exchanger. And from the heat exchanger, the red colored one is nothing but the steam flows into the turbine, and the turbine is connected to the alternator, and output of the alternator is connected to the transmission line. So the output of the turbine is once again connected to the condenser, and the purpose of this condenser is to cool down, okay, convert the vapor into liquid, and this hot steam will be sent into the cooling tower, and the cooling tower is connected with the air, where it gets cooled down our vapor, and it will send the water to the base, and the water will be once again some remaining water will be taken from the river, and the completely cold water will be once again sent to our condenser. The purpose of this condenser is very simple. It converts the vapor into liquid. Okay, so therefore we are going to see here, we are going to have the three loops here in this one. Okay, so this is called loop 1, this is called loop 2, and this is called as loop 3. That's how these three loops are interconnected, and which make us to continuously generate the power using a nuclear power plant. Okay, so this is all about the heat exchanger, turbine, alternator, as well as the condenser. Okay, let's have some small discussion about what are the different components we have been studied now. Okay, so please everyone unmute your mic. Thank you for listening patiently. Please unmute your mic. Hope you are able to understand the parts.
Yes, sir.
Yes,
Okay,
sir.
is it clear, everyone?
Yes, sir.
Sir.
Please everyone unmute your mics. Let me have some discussion with you. Thank you for joining, around 27 members. So hope those are interested, you can join, and I will take the attendance, and I will consider this attendance for your lab only. Okay. So what are the components had we discussed? Let's try to have some small review. So give the response. What the first part we have in our nuclear reactor? First one is,
Fluid.
yeah, fuel. It's nothing but reactor. In this reactor, what are the parts you are going to have? First one is,
Yes, sir.
very good, super. Fuel rods. Next one is control rods. Next one is
Moderator.
moderator. So fuel rod is made up of uranium. Is fuel. Fuel is nothing but what? Uranium. Control rod is made up of cadmium.
Cadmium.
Very good.
Yeah.
Moderator is made up of graphite. Okay. All these three
Okay.
are inserted in the reactor, and this reactor is going to produce and heat energy. So here you can see the how the reactor, I mean the nuclear fission reaction. So fission reaction is nothing but splitting. So it is going to produce the energy. And here some extra neutrons are produced. This can be slowed down with the help of an moderator. Already I have been discussed about the moderator. This automatically this neutron will be slowed down, and continuously it will be hitting our nucleus or the fuel rods in order to complete this reaction. Okay. Now, what are the remaining parts after the reactor? What are the remaining parts after the reactor?
Turbine.
Just you can see the video and you can see here. So what are the remaining parts after the reactor? We have heat exchanger.
Heat exchanger.
Yeah, what is the purpose of this heat exchanger? The name itself, it exchanges the heat. So here we have two types of reactors. What are the two types of reactors we have? Pressurized water reactor, and next one is boiling water
Boiled water.
water
Boiling water
reactor.
reactor.
So these reactors are of two types. In this pressurized water reactor, so water will be adding as an cooling agent, and it will be
Coolant.
circulated in your heat exchanger, and the total heat energy is converted into which energy? Steam energy. And the steam will run our steam turbine, and
Turbine.
the remaining steam will be sent into the cooling tower, which will convert the steam into water, and once again it forms. And how many loops are there in this plant? So internal loop,
Three
this
loops.
is loop 1. Very good. So where this loop is connecting only reactor as well as the heat exchanger. Another loop connects heat exchanger, turbine as well as the condenser. So third loop is there. That loop connects our turbine, alternator as well as the cooling tower. Three loops are there. Okay. So the main advantage of this, the exam we get a question like describe the difference between pressurized water reactor and boiling water reactor. Okay. So here, what is the coolant we used in pressurized water reactor? Water. Here you also use the water only, but in boiling water reactor there is no need of a heat exchanger. Okay, this heat exchanger will not be available directly. The steam will be available from the reactor and it directly connected to the turbine and it moves. Okay, just to skip this heat exchanger, then it will be acting like a boiling water reactor. Okay, so now what are the remaining parts after the reactor? Everyone respond. Very good. Steam turbine. The purpose of the steam turbine is to convert mechanical energy to electrical energy. Okay. So here you are going to convert this steam energy into mechanical, and the remaining action is taken by our alternator. So what are the two parts in an alternator? Very good. Stator and rotor. Which part we are rotating? Very good. Which part we are rotating? Rotor part we are rotating. Why? Because it is rotating. And EMF is produced in stator or rotor? Stator. Stator is consisting of which winding? Armature winding. How much EMF is generated is 415 volts EMF is generated. Okay. So here you can see the how physically a nuclear power plant is there. Is it visible to you? Yeah, this red color indicates that this is nothing but high pressure, which is nothing but steam. Red color one is nothing but it is having high pressure, steam is there, and this why it's shown in red color. And blue color indicates that this is like in water, like normal cooled water. That's why it is shown in blue color. So the control rods, moderator, and this everything will send the steam to our heat exchanger, and from here the red color steam will rotate our turbine, and turbine is connected to alternator, and alternator is connected to the transmission line. And you can see the diagram of the condenser. What this condenser is going to do, it is going to convert this steam into water. Steam is in red color, uh, this water is in blue color, and this will be connected to a nearby lake, and automatically it cool down, and it is once again pumped to our heat exchanger. So are you interested to see the animation of this video? If you are yes, please speak out.
Yes, sir. Yes, sir.
I'm not getting much response. If you're more interested, I can make the things very clear and very systematic.
Yes, sir.
Yeah,
Yes, sir. Yes, sir.
yeah, good.
Sir,
So can you, yeah, come again? Yeah, someone has given one clarification. Come again, I don't understand. Okay, so I will make you the things more clear. You just watch this. One second. Okay, see here. Is it visible to all?
Yes, sir.
Yeah.
Yes, sir.
Yeah, what you understood now?
Yes, sir.
So this is an animated video to show you that the control rods, moderator and fuel rods will generate the heat, and that heat is converted into steam, which is a process called a heat exchanger, and the steam will make our turbine to rotate, and the turbine is generating the power. You can see the electrical shock, electrical voltage is generated, but the remaining hot steam will come into, yeah,
The screen is not
it's not visible.
yes, sir. Not
Yeah.
visible, sir.
Okay, one second. Did you lost the connection or it is visible?
Screen visible, sir. Video not playing.
Okay, video is not playable, right? So now screen is
Yes,
visible.
sir.
Yes, sir.
Yeah. So this is why, because online is not supporting animation. So I think it's not visible. I will show you in the class.
Okay,
Okay,
sir.
sir.
Yeah. So this is like a cyclic process. Let me wait. I will. Okay, so this is all about nuclear power plant. So shall we continue with the next topic, like advantages and disadvantages, or can you prepare from ChatGPT? Yeah, I want the response. Why? Because everything I have been discussed, nothing is
Yes,
left
sir.
over. So shall we go ahead with advantages and disadvantages, or let's try to go
Okay.
with another plant of power generation?
Advantages and
Okay,
disadvantages.
good. You better have some running notes parallelly. It will be very good for you to continue also.
Okay, sir. Yes, sir.
So don't think that this not regular class. Why? Because no continuously it is controlled by online. So you may have some lags or glitches in the video. Just try to understand. Now the screen is visible.
Yes, sir.
Yeah. So put the subheading advantages of nuclear power plant. Now till now we had discussed a lot of things. Now let's try to discuss about the advantages. So advantages of nuclear power plant. First advantage is here and small amount of fuel is sufficient. Okay, already we discussed in the first point. So how much amount of fuel is required? 1 kg of uranium is sufficient to generate how many tons of heat energy? 4,500 tons of fuel has to be burned to generate equal amount of heat. So this is how we are going to say that 1 kg of uranium is equal to, so if you burn 1 kg of uranium, it will generate an equivalent of heat which is equal to 4,500 tons of coal we are going to burn, which is also going to produce the same amount of heat energy. That's why the amount of fuel, so the point is, so the amount of fuel required in nuclear power plant is very less. The fuel requirement is very less, and here this is the cheapest source of electricity generation. So here we can generate the power with low cost, therefore it's called cheap source of electricity generation. Sir, what is this low cheap cost? It constitutes only rupees 4 rupees to generate 1 unit of electricity. And third advantage we are going to have with this nuclear power plant is to construct this nuclear power plant, we may require less space. I mean, the space required is very less when you compare with the remaining thermal plants, or when you compare with hydro plants. And these plants are going to, are, I mean, this nuclear power plant is more economical in cost wise also. So the unit cost is very less, but when you coming to the unit cost of thermal and hydro, these are little bit in higher amounts which we can understand here. So nuclear power plant will constitute only 4 rupees per unit of generation, and thermal plant is also around 7 rupees per unit, and hydro plant is 4 rupees per kilowatt, as well as the solar plant is only 2 rupees, 2 rupees 30 paisa per kilowatt. So you can see here which is best is nuclear is best, after that hydro is best, after that the thermal is best. Okay, so this how this power plants are very efficient, especially nuclear. We have this I mean nuclear power plants in Tamil Nadu. Okay, so therefore these are cheap source of electricity. They occupy less space and they're most economical in generation of unit cost. Okay, so these are the advantages, and these are highly efficient, so than compared to thermal plant, these are efficient to produce a large amount of power in terms of megawatt of power also we can produce. These nuclear power plants are efficient and they are capable of generating a large power capable, I mean large amount of power can be generated. And coming to the advantages, one more advantage, large amount of uranium as well as plutonium is available in our world, and this may be lasting for upcoming 1,000 years also. We can generate this nuclear power. So that's why the fuel is also completely available, and we can generate up to 1,000 years also. And here there is no pollution like the thermal plants. This is an neat plant, as well as is an clean plant compared to our thermal plants. Okay, so these are the main advantages. You can see here the fuel requirement is less, and this is a cheap source of electricity. They occupy less space, and they are more economical in terms of per kilowatt, and they're very efficient in generating maximum power. And this uranium and plutonium where we use in fuel rods can available in the world, and we can run these plants for the upcoming 1,000 years. And the main problem here is the radioactive radiation. So basically this uranium and plutonium are radioactive material, and they may lead to radioactive radiation. When you touch this radioactive radiation, you may get some skin diseases or some asthma type of diseases. That's why these plants are not much suitable where the human people are living. Okay, now how this plant has advantages, they are also going to have the disadvantages also. So coming to the disadvantages of this plant, the installation cost of this plant is too high. Okay, so when you want to install, we need to have a lot of installation cost or capital cost to invest than compared to thermal plant or nuclear plant. And basically this nuclear fuel is very expensive. This uranium and plutonium is expensive, so therefore it's not much recommended to construct these nuclear power plants. And there's one more problem in controlling the nuclear power plant. So in order to control, it's not much easier. Okay, so why? Because this nuclear fusion reaction is an chain reaction, and sometimes if you don't have a proper professional in handling this plant, it may lead to explosion also. Okay, therefore the controlling of this power plant is very tough. So if you want to run this plant, you require an highly knowledgeable experts to run this plant. I mean, experts are to be required to run this. Okay, and whenever experts are driving it, already these experts salary is also high, and the maintenance cost of running this plant is also high. So automatically we require more expert, we have to pay more salary, and automatically the running cost will be also higher. And one more problem is this radioactive material, which is nothing but uranium and thorium. So this radioactive waste, I mean, when you burn this fuel rods, this radioactive material will produce poisonous chemicals. So when you inhale this, this is producing the poisonous chemicals, and this poisonous chemical absorption is called radioactive contamination. Radioactive contamination. So what is the problem with this radioactive contamination? It will first kill our blood cells. Okay, so it may damage our living cells. Sometimes it may cause burning. So it may burn, it may create some sort of burns on your hand, and it may create some diseases like illness. And in the future, if you are near to this plant, you may got lot of health diseases. Okay, or you are going to have adverse health effects. So these are all the drawbacks. And one more drawback is these plants are not respond very fastly. The load is varying very higher. I mean, around. Let's assume that we are turning on 100 ACs at a time. This plant cannot dynamically respond. There's one more drawback. So these plants do not effectively respond with the variation of load demand. So these are all the disadvantages. So the installation cost is higher, and basically this uranium and plutonium fuel rods are very expensive in nature. And to control this nuclear power plant, you may require control rods, or you may require moderator. So sometimes if it is uncontrolled, it may lead to explosion. And in order to control this plant, we require expert people, which is one more drawback. To run these experts, more salary has to be paid. One more running cost is increased. It's one more drawback. And this radioactive material or like a poisonous chemical after they get burned out, and they are going to create an contamination or damage to the human cell. So the living organisms, your skin will get burns, and you may get some dizziness, and you may be affected with health hazards. And this is not suitable whenever the demand is high. At the morning time, if the demand is very high, this plant cannot handle. So this is all about the nuclear power plant. So I have an very good animated video, but I don't know the reason why it is unable to play the GIF file here. So this is all about the advantages and disadvantages of a nuclear power plant. Okay, so now let us try to go with another power plant, which is nothing but a solar power plant. Okay. Hope everyone is able to understand. Shall we proceed with the another power plant?
Yes, sir.
Yes, sir.
Okay. Do you want any break?
No, sir.
Okay. Okay. Now let's try to go with solar power plant. Let's try to take some break for 5 minutes, and don't leave the meeting. We'll join in 1 or 2 5 minutes. Okay. Right. You can take a small break, relax with water, and come back.
Okay.
Okay. Hope everyone is available in online. So everyone unmute your mic. Shall we start going forward? Okay. Shall I start the meeting?
Yes, sir.
Yes,
Okay.
sir.
Hope
Yes, sir.
you have been refreshed and we are going to start the meeting. Okay.
Solar.
Yeah. Anything else? Aisha.
No, sir.
Yeah. Okay. So now we'll discuss about the solar power plant what we have in our college. Okay. So now this is also very interesting and this is trending in electrical engineering how we generated the solar power. Okay, so let us try to have some structural view and let us try to go ahead. You can see here, so this is called as solar panel. This is solar cell. Okay, and this group of cells are connected in series connection to generate a solar panel. So this is panel 1 and this is panel 2. These two panels will generate a solar array. Okay, the output of this solar panel is nothing but an DC supply, and this DC supply will be connected to an DC isolators or fuses, and this DC supply will be connected to an AC supply with the help of an grid connected inverter. So this is the diagram of a grid connected inverter, and here we are going to have an AC isolator. Okay, from this isolator we can connect our AC supply to our home. Okay, from our home we can connect to our light, we can connect to our tube lights, we can connect to our AC, and from the same AC output we can connect to a meter, where this meter is called as a net meter. The purpose of this meter, we can export the power when you generate excess, or we can import the power when you have lesser amount. Okay, so this way of generating power is called as a solar photovoltaic system or solar PV plant. So these are very trending in the world, and we are having PM Suryagar Bijli Yojana to encourage this plant, and this is very interesting in the department of electrical mechanical is very very interesting, and lot of scope is there for the futuristic of India as well as in Andhra Pradesh. Lot of plants commissioning is also going on, and we have been successfully erected in our college, and you can see in your block you are going to have the total 300 kilowatt plant is there. So in your block, you are going to have 150 kilowatt rated, and in electrical block, you are going to have one more 150. Total is going to have in our campus, we are going to have 300 kilowatt. Okay, so I don't want to go more detail. Why? Because our focus will get distracted. We'll try to discuss only about the components. Okay, so in some other free time, I will show you the practical. Okay, now let us try to discuss one by one. So first one is let's try to see what is this solar power plant. Okay, so already we have been discussed in the previous class how to generate the power using water, and how to generate the power using nuclear energy, and we had already discussed how to generate the power using tidal energy. Okay, now let's try to see here how to generate the power using a solar power plant. Okay, so this is the diagram corresponding to that,
Sir.
how it will be working. Okay, so first one, solar power plant. Here, generation of solar power plant is very economical and ecological. Okay, so this is an ecological source, and basically this solar energy is an renewable energy. Okay, so renewable means reuse we can reuse multiple times. Okay, there is no end, so the solar energy is an unlimited energy. Okay, please everyone unmute your mic. Some disturbance is going on background. Please kindly cooperate. Please unmute your mics. Right. Please everyone unmute your mic. When you ask you can mute your mics. So this is an renewable energy, and this is an unlimited in nature. Okay, and this is an renewable source of energy, and with the available renewable source of energy, this solar energy is an efficient kind of energy. Okay, and here this solar power is of one more type. So there are two types. One is solar thermal energy, that also we will discuss, and also we have solar photovoltaic plants also we have. Okay, so this is what today we are discussing about solar photovoltaic plants. Now let's try to discuss what is this solar PV system. Okay, so let's try to discuss about the solar panels. Solar panels. Okay, so whenever you can see here, these are called as solar panels. Whenever our sun radiation, the light energy, so the light energy from the sun bombard our solar panel, automatically this light energy is converted into voltage. So those kind of panels are called so I mean this process is called photovoltaic effect. Okay, photovoltaic effect. So what is this photovoltaic effect means? Our light energy is converted into voltage. What kind of voltage is DC voltage? Okay, so the voltage will be like this. This is voltage, this is time, and it is going to generate an output voltage of 12 volts. So the output of the solar panel is what kind of power is DC supply. Okay, and these solar panels may be connected in series connection or parallel connection. Let us try to take this is solar cell. Solar cell will generate voltage, and all this will be connected in series connection, and ultimately the output of the solar panel is a DC supply. And let us assume that this is an 100 watt peak solar panel, and it is generating some 12 volts, and we are going to have one more 100 watt peak solar panel. It is going to have positive polarity and negative polarity. So and the output of the solar panel is also 12 volts, but resultantly I require to my charge controller as only 12 volts. Then join this positive and this positive, and join to this positive, and bring out this negative, and bring out this negative, and join to this negative, where this is called negative. Okay, so like this you are going to have positive as well as negative. We have been connected, and to this we can directly connect to an charge controller. Okay, so this is called charge controller, which regulates the output. So sometimes solar radiation will be less. I mean, we may have some shadow, and automatically the voltage also will decrease. And here we are going to connect this charge controller to an fan. Okay, so you can connect it to an fan, or you can connect this to an bulb. Okay, so whenever the solar radiation is varying, automatically bulb also will reduce its illumination. If the solar radiation is decreasing, fan also will decrease its speed. Okay, so these kind of systems are called as a PV direct system. So directly without the help of an battery, they are connected to the Solar panel is connected to the charge controller. From charge controller is connected to the load. So these kind of plants are called as a PV direct plants. There is one more type of solar plants which are called as a off grid. So if the meaning itself is says that, so these plants are not connected to grid, so there is no grid. Okay, so where this solar panel is, so here when you're not having grid, the extra amount of energy generated by the solar plant has to be stored by the batteries. Those batteries may be connected in series or parallel, and we will require an inverter, so which is nothing but to convert the DC supply of the system to AC supply. So this is all about off-grid system, and you're going to have an on-grid system. In an on-grid system, here this solar plant is connected to an inverter, and this inverter is called grid connected inverter or grid tied inverter. Okay, and the purpose of this inverter is connected to an meter, where this meter is called as a, this meter has the capability to export the power as well as it can import the power, where this meter is called as a net meter. So this meter will be provided by the government after you apply for PM Suryagar Bijli Yojana. After applying to PM Suryagar Bijli Yojana, this plant has the capability to export the power or to import the power, that is done by a meter called net meter. Okay, so coming to the basic components what we have in an solar power plant, here you can see in the diagram. So first component is this is called solar panel 1, this is called solar panel 2. These two solar panel will constitute, they are connected in a parallel connection, they will constitute an PV array, and group of solar panel is called as solar array, and the output of the solar panel is an DC power or DC supply. And to protect this solar panel from lightning or from short circuit, we are going to have fuse protection, which is called DC isolators. Okay, so here we are going to use HRC fuses. What is HRC means? These are called as high rupture capacity fuses, where these are high DC fuses. Okay, and here it is DC supply is available. When you, in our home we have AC supply, bulb is of AC supply and AC is of AC supply, and we have a geyser of AC supply. But we need to convert this DC supply into AC supply suitable to our home. This is done by an component which is called as an inverter. So this inverter will convert this DC supply to AC supply, and after connecting to the AC supply, we need to connect this to our meter. So where this meter is called the AC isolator, which is nothing but, here we will discuss in the next class. Here we will use MCBs, as well as we are going to use isolators of required 40 ampere rating or 100 ampere rating. So after connecting to the isolator, we are connecting to the distribution box. From this distribution box, once again the supply is connected to the meter box, where this meter is called as net meter. This meter can export the power to the grid, or they can import the power to the grid. And this, from this distribution box, they are connected to the lights, as well as you can connect to fan, you can connect to a tube light, or you can connect to any AC appliances what you have in your home. Okay, so this is very trending in electrical engineering, how to generate the power using solar energy. Okay, so I will give a small logic how we do at our campus. So actually we have an 150 kilowatt plant in our campus. Okay, so at we have this 150 kilowatt plant in our electrical block, and one more 150 kilowatt plant in our academic block. Okay, so in this 151 kilowatt plant will approximately generates 5 units of electricity, which is called as 5 kilowatts of units per day. Okay, so for example, let's try to calculate how much amount of power we are generating per day in our campus. Okay, so coming to here, total is how much? 300 kilowatts. So total rating 150 plus 150 is 300 kilowatt plant is there, and each plant, I mean each plant, 1 kilowatt will generate 5 units. So automatically per day we are generating 500 units of power we are generating in our campus, or this number of units we are going to call it as kilowatt hour. So in this 1500 units, now today we have an holiday, right? So already our solar system has generated 1500 units. This 1500 units will be exported. Okay, this is the power exported by our campus today. So when you are in the college now, the same these 1500 units we will be consuming. Okay, so here you can see in this diagram, so our solar panels are there at the top. They convert the DC supply to AC supply, and we have the inverter, and it's connected to the here. So now our solar plant has generated how many units? 1500 units, and no one is there to consume, turn on the fan or light or the computer. Therefore, total 1500 units of power has been exported to government, and they are going to pay us in the cost of 1500 units at a price of 5 rupees. So today we have been generated a revenue of 7500 rupees. So due to holiday, we our campus has been getting benefit of 7,500 rupees. But when you have the campus today, or when you have the college today, so the total power which is generated will be consumed by the classroom, computer labs, and different labs, and automatically this 1500 units will be consumed by us. This is how we generate the power, and this is how the total plant we have around. We have 480 panels in electrical block, and one more 480 block panels in academic block. So approximately we are going to have, so totally some these panels are available in our block. Okay, so like this totally approximately around 960 panels are available on group of 300 kilowatt plant in our campus. This is how we generate the power one by one. So these are all about the basic components we have in the solar power plant. Okay, now let's to understand the cost of the solar plant. Okay, so let's try to have a small revision. Please everyone unmute your mics. Yeah, everyone unmute your mics. Is it visible to all?
Yes, sir.
Yeah. Now give me the response. So what is the output of an solar array? AC supply or DC supply?
DC sir.
Very good, DC supply. So what is meant by an array? So here it is said as array, right? What is meant by an array?
Solar panel.
So solar panels may be connected in series connection or in parallel connection. Very good. So when more than one solar panel is connected in series or parallel connection, then it is called as an array. Okay. So what is the output of the solar panel? AC supply or DC supply? DC supply. But what is the power we have in our home? AC or DC? AC. What we need to do? We need to convert this DC supply to AC supply. How to convert this DC supply to AC supply? Very good. So this is called inverter. We also have an inverter in your home. Okay, we have a batteries and a DC supply. We'll convert the DC supply to AC supply with the help of an inverter. Okay, and after connecting to the inverter, what is the output of an inverter? AC or DC? AC supply. So this AC is connected, and we are connected to the fans, lights, computer labs, everything. So and there is one more meter. What is the name of this meter? What is the name of that meter? Very good, net meter. What is the purpose of this meter? Is it can export the power or it can import the power. So today we have holiday. How many units we have been exported today? 1500 units. Okay, 1 kilowatt plant. So totally we have 300 kilowatt plant. So 1 kilowatt plant will generate how many units per day? 5 units per day. So 5 into 300 is how much? 1500 units we have been generated. And how much government is going to pay is 1500 into 5. I mean 300. So 300 kilowatt plant into 5, totally 1500 units. So this 1500 units are generated. Okay, so therefore, on an average, we have been generated 1500 units. And how much amount of cost is generated? I mean, rupees, how many rupees is generated? 500 rupees is the saving due to this holiday. That's what you have to understand. Okay, hope you got a clarity.
It is
Sir.
Yeah.
interesting.
Yes, sir.
So this is a very innovative technology. That's why we implemented this in our campus. And now, is our college solar powered or normal powered?
Solar power.
Solar
Solar
power.
power.
Hope at least by this video you will get a clarity that our campus is completely solar powered, and we are consuming the power of your tube lights and fans, computers, everything in the campus is operated with which power? Solar power.
Solar power.
Okay, so this is how we have an solar plant in our campus. Now let us try to see here what is the cost of each plant. Okay, so you can unmute your mics and just you can listen. Okay, such a way that disturbance will not be there. Okay, so coming to the solar panel, what is the cost of this each solar panel? So if you want a 1 kilowatt solar plant, the cost of this solar panel is approximately 45,000 rupees. And you should know how to place this solar panel and where to mount this solar panel. Okay, so after the placement of solar panel is very important, and mounting of the solar panel is also very important. So if you have to mount the solar panel such a way that throughout 365 days our solar panel should be subjected to light energy. In such a way we have to mount our solar panel. And coming to the life of this solar panel, they are designed with a life of 25 years. 25 years our campus we can generate 1500 units per day. Okay, so the number of units we can call it as a kwh. And coming to the already we discussed we how to convert a DC supply into an AC supply. This is possible with the help of an inverter. Okay, so this inverter is going to convert the DC supply into AC supply, and it will produce an output supply in a single phase supply as a 230 volts single phase supply, as well as 50 H. Or if it is a three phase inverter, it is going to produce 415 volts three phase supply in the sequence of RYB. Okay, so this 230 volts, 415 volts are RMS quantities. And what is the cost of this inverter is 15,000 rupees per kilowatt. So if you are having an 3 kilowatt inverter, so it is 45,000 rupees. And coming to the tracking, so we have to track our solar panel. How to track our solar panel is also very important. Okay, so we can for example, we have a solar panel. So this is nothing but east direction. To what I am sitting now is east direction, this is west direction, this is south direction, this is north direction. Can you say what we have in south? At south what we have? Tamil Nadu. Okay, so like this, when you place a solar panel, so solar panel has to be rotated from 0 degrees to 180 degrees. Like this, it has to rotate. Rotating in uh, horizontally, or rotation of the solar panel is called as azimuth angle. Okay, and coming to the structure, so the solar panels, so this is nothing but our solar panel. We are keeping with some inclination. This inclination angle we are going to call it as a elevation angle. So all the time, remember, we have to face our solar panel in which direction is south direction as per our latitude. So solar panel should be facing south direction. That is called as azimuthal angle, and they should be kept with an inclination. That inclination angle is called as the elevation angle. Okay. So this way of placing in azimuthal angle as well as elevation angle is called as a solar tracking. Okay, so this azimuthal angle, so we can rotate our, so for example this is your solar panel, so we can rotate our solar panel 360 degrees, therefore azimuthal angle varies from 0 to 360 degrees. But elevation angle is nothing but solar panel tilt. So here you can see here, so this is the solar panel, so we can move it to 30 degrees, 45 degrees, and you can keep it to 90 degrees. Okay, so this is our solar panel. The maximum we can rotate our solar panel, or you can have the elevation angle in a solar panel is only up to 90, but you can rotate our solar panel as per our requirements. So this is all about the solar panel. Okay, now let us try to discuss about one more type of solar panel, which is nothing but called as concentrated solar power. Okay, so this is also not much popular, but this type of solar power generation is also there. So this is called concentrated solar power. So what is this concentrated solar power? So here we are going to have the sun. Okay, so I will show one image such a way that you can get an clarity. Is the image visible to you?
Yes, sir.
Yeah,
Yes.
Yes, sir.
yeah, good, good. So please be interactive. The class will be a little bit interesting. Otherwise, it's like I'm speaking continuously where you don't understand anything. So this you can see here. So this is called as a solar power tower. Okay, so this comes under the classification of concentrated solar power, and these are called as solar power towers. So in the exam, you'll ask you, explain me about the solar or concentrated solar power. Okay. So here you're going to have our sun, and here you're going to have the mirrors. Okay. So the mirrors are placed with some inclination, and the solar radiation will hit these mirrors, where these are called as mirrors, or these are called heliostats. So is anyone writing running notes? Anyone?
Yes, sir.
Yeah, good.
Yes,
So
sir.
this is called as sun, and these are called as mirrors. And as soon as the sun hits our mirror, and these mirrors are called a heliostat, they will get reflected, and all these reflected rays from the sun will be absorbed by an heliostat. Here you can see here. So these kind of structures are available, and this is the working fluid we have. So the working fluid will go to the turbine, and the output of the turbine is connected here. So I have been shown this working fluid in red color, which indicates that this is producing an steam energy. Okay, the water is converted into steam. Okay, and the at this point all the solar rays are concentrated in nature. All the solar radiation get concentrated at this point, and at this point we are going to have a large amount of fluid is going to get heated up, and this fluid is called the working fluid, and this is called the solar tower. Okay, so this completely, so you can see here, this is called solar tower, and these are called as sun radiations, and these are called as mirrors. Okay, all these are solar mirrors, where we call it as heliostats, and all are observed at this point, and in this we have an working liquid. I mean, this is called as working fluid. So inside this one we have working fluid, and this fluid will convert this complete heat energy into a steam. Okay, and all the solar radiation is get concentrated at this point, and this is called the solar tower. And here you can see here, and this steam is going to run an alternator, and this is converted into an electrical energy. Okay, so this is are of these type of structures. Okay, so these type of structures are of three types. One is called parabolic trough type, and second one is called as a sterling dish. How we have our dish tower Tata Sky, like this, these are of sterling dish type. And this is called the third one, the solar power tower. So this is what we have been shown in the figure is solar power tower. So this is how we have the parabolic tough type sterling dish type. So this is how to understand how we generate the power from solar energy. That's how we are connected with each other. Okay. Now this is all about the solar power plant, and in the upcoming video we'll try to discuss about how our wind plant will be working. So shall I continue or we'll take some break? Hello. Shall we
Continue, sir.
Yeah. Okay.
Continue, sir.
Yeah. So just 5 minutes break I want. Just to also take some 5 minutes break, and we'll continue with the wind plan. Just those who not written the notes, you can write the notes now. Okay.
Okay, sir.
Yeah. Just write down the notes. Those are not written the notes. So I'm reducing the zoom. You can write the notes. So just this is the diagram what you have to draw for a solar power plant. Yeah. Okay, students. Hello. Hello. Yeah. Is the animation visible to you? Yeah.
Yes, sir.
Yeah. So,
Yes,
what
sir.
you understand? Can you brief out? What you understand? Can you brief out? Anyone? Nani.
Sir,
Yeah. Just explain by seeing the animation.
sir, solar rays,
Yeah.
sun
Very
rays,
good.
solar panels,
Yeah. You can speak in convenient language.
ఈ సన్ రేస్ సోలార్ ప్యానల్స్ పైన పడుతున్నాయి సార్. అది ఎనర్జీ ఏంటంటే బ్యాటరీలో సేవ్ అయ్యి
Yeah.
ట్రాన్స్ఫార్మర్స్ ద్వారా
Yeah.
హౌస్కి
Good.
వస్తుంది.
Yeah. Good. So here you can see here any other student can give an I are given some theoretical explanation. This is an animated video. You will get more picture than theory. So any other student can explain this what's happening here. Any other?
సార్
Yeah, good.
సన్లైట్ అనేది సోలార్ ప్యానల్స్ మీద పడుతుంది సార్.
Yeah,
అది
very good.
పడి
Yeah,
బ్యాటరీలో సేవ్ అయ్యి
yeah, yeah, good.
అది ఏసీ నుంచి డీసీ నుంచి ఏసీ కన్వర్ట్ అవుతుంది సార్. ఇన్వర్టర్ ద్వారా
Very good,
కన్వర్ట్
super.
అయ్యి
Yeah.
ట్రాన్సిస్టర్ లోకి వెళ్ళి హౌస్ కి ప్రొడ్యూస్ అవుతుంది.
Yeah, very good. So that's what I was giving explanation. This is sun radiation. From sun, what you're going to get is heat and light. But this solar panel require only light energy. That's why these are called photo means light, voltaic means voltage. So this is solar panel one, solar panel two, solar panel three. All these three are connected in series connection. Automatically, we had got this DC supply, and this is nothing but our converter. So this is like hybrid, so we can use this solar power and we can store in our battery. This is nothing but our inverter at your home, and the same DC supply will be connected to an hybrid inverter. So where this hybrid inverter will convert this DC supply into AC supply, and same AC supply will be exported to the grid with the help of an transformer. So when you want more power, I mean we have more demand, we can observe this also. You can see here sometimes it's going up and sometimes it is coming back, which indicates that more solar radiation is there. And there is, for example, can anyone say what is the flow of direction when we don't have a load here? So for example, today we don't have the campus. I mean this is our campus. We don't have the load here. The power will be exported or imported? Very
Exported,
good,
sir.
super. Why? Because we don't have load, no fan,
No,
no
sir.
tubeless is there. Automatically, here you can see here the power will be exported. What will happen tomorrow?
Import.
ఇంపోర్టెడ్.
Import. Import means actually import will not happen. Actually, the power what we generated, we will consume 1500 units what we require. For example, in our campus we are having more than 1500 units. For example, 2000 units we have in our campus. Why? Because tomorrow all the labs, everything, all the campus will be on. So we have generated only 1500 units. How much extra units we require? 500 units. Okay, so that 500 will be imported from the grid, and that's how it works. Hope previous I was unable to show the animation. Now it is clear.
ఎస్ సార్.
So please give your response where the class will be little bit interesting and interactive in nature. Yeah, is it clear?
ఎస్ సార్.
Yeah.
సార్.
So previously we have been missed one video that also we will see here, the animated. So this is the nuclear power plant animation. Now is it visible?
ఎస్ సార్.
Yeah, give me the
Yes, sir.
explanation. Those who had already listened the class, give me the explanation. Anyone please speak out? No one. So see here, what happens is here we have control rods, moderator, and fuel rods. All this will burn, and what they are going to generate is an high amount of energy. That high amount of energy with the water it will combine and it will reach our heat exchanger. From heat exchanger, the total heat energy is converted into what? Steam, and the steam will run our turbine. So as soon as your turbine is rotated with the help of steam, automatically our generator will start generating the power. Okay, and the turbine is continuously rotating, and the turbine output is a steam, and we need to cool our steam that is made with the help of cooling towers, and the total water will be sent into the heat exchanger, and it will be available. So this is how our controllers, and what is the purpose of a control rod, can anyone say? This is used to control
Control the
To control the neutron.
yeah, very good, the flow of neutron. To control the rate of what is the chain reaction, we can use the control rods. Control rods are made up of which material?
cadmium.
Very good, super. Okay, and the moderator is made up of which material? Graphite. Okay, so
Graphite.
this is how the animation is there. Is regular class interesting, or these animated classes are interesting? Huh?
Animated
Yeah,
classes.
but
Animated class.
yeah, that's why I was planning to take online class where I can give more knowledge rather than speaking. So sometimes it may be possible that like this to take online class, sometimes only on the board I have to teach. That's why you got some clarity on this. So what is the feedback on the class? We have been completed solar and nuclear. So what is your feedback? Is a regular class is good, or this online class is good?
Both are good.
Both are good. Thank
Both
you.
are good.
Yeah. What you are able to understand more on regular classes? You're, yeah, regular class you are able to understand, or these classes you are able to understand more? Which classes are able to understand more?
Online classes. Online classes.
Online, good. But all the time it's not possible. We require some projector and network. Okay, good. Anyhow, so now let's try to go ahead with the another interesting concept. Put the subheading. Hope you understood this diagram now, right? Yeah. So
Sir,
this is like physically, that is like dynamically it is moving. Therefore, you got more clarity. Right. What is the name of this plant? Anyone?
Solar power.
Solar power
plant.
tower, not
Solar
plant.
PV.
Power
Solar
tower.
power.
Okay. This like these are there in foreign countries. We don't have in India, but solar PV system we have in India. In especially we have in our campus. Okay. So now let us try to go with wind power plants. Okay. Put the subheading: power generation using wind wind power plants. So now let us try to see here how to generate the power using an wind plant. Okay. So let us try to have one diagram, and we'll go ahead with the explanation. Okay. So first I will give an normal class, and then we'll go for the design. Okay. So the same diagram you have to draw in the exam also. Okay. So see this diagram. So these are called as mechanical brakes, and this is called as gearbox, and this is called as nacelle, and this bottom structure is called pivoting system. Okay. Right, you see here. Now let's try to discuss about the wind power plants. What these wind power plants are going to do, and what are the plants? Still now we have been discussed. We have been discussed about how to generate the power using hydro. We have been understood how to generate the power using nuclear energy. We have been understood how to generate the power by using a wind power plant. Okay.
Or
So what are the parts we are going to have is the first one we are going to have, which is nothing but the blades, and these are the blades. So this is nothing but to control the speed of these blades we have an mechanical brakes, and to increase the speed of this rotation we have an gearbox, and this gearbox is connected to an, so this is nothing but generator. What kind of generator this is? AC generator. This AC generator is called as alternator, and all these parts are present in an one component which is called as an nacelle, which is nothing but the big box of an wind turbine generator is called as a nacelle. All the components are there only in nacelle. So pivoting system. This like we can rotate our plant 360 degrees. These kind of systems are called pivoting system, where the turbine will rotate from 360 degrees, which is possible, and the blades also here we can rotate. This is also possible. And what kind of power we are going to generate from the alternator is AC supply, and this AC supply we are going to transmit to an, so this is our campus, and we are IST, and this power we are generating at Nellore, at Nellore station we are generating the wind plant, and the AC power has been converted, and we are using a step up transformer, and we are sending the power through the transmission line through Manubolu station. Our power gets reached to the NBKR college. This is how we have the step up transformer. These are called as a transmission line, and our load where we have fan tube light is nothing but NBKR college. Okay, so this is how we have the generation of wind power. So what happens is actually let's try to discuss point by point, then you'll get an clarity. Okay, so actually wind energy is an sustainable energy. Okay, so this is an a sustainable energy, and sustainable means this is an long lasting energy. I mean it's available in unlimited in nature, so there is no limit for this energy. It is a long lasting energy, and it is an unlimited in nature, and this wind energy is environmental friendly. Okay, so these kind of energy resources are called sustainable energy, and basically wind energy is a renewable energy. Okay, so we can use this energy. There is no end to this energy, therefore these are called unlimited energy. Okay, so by using this wind plant we are going to convert our wind energy into electrical energy, which is nothing but as voltage, current, as well as power. And how these wind turbine plants will operate is so we have an aerodynamic blades. So by using these aerodynamic blades, we will use these aerodynamic blades, and from these blades we are able to convert this wind energy into mechanical, and from this mechanical energy we are going to rotate our rotor. As soon as our rotor rotates as per the Faraday's laws of electromagnetic induction, one, an EMF is generated in the stator, where this device is called alternator, where this alternator is also called an AC generator. Okay, so what actually this wind turbine generator is doing is, so wind is going to have the kinetic energy, or your wind is having kinetic energy, where kinetic energy we are going to convert into mechanical energy. From mechanical energy we are going to get the output electrical energy. The output electrical energy may be a voltage, current, or power, or energy. Okay, so you can install this wind plant on roads. So on normal roads we can install, or we can install them at the seashore. I mean, near to coastal area also we can easily install, or we can combine this with solar also. Wind plant we can combine with solar also. We can generate the power. Okay, so here the technique is very simple. Already I told, the wind starts struck the aerodynamic blades, and the blade starts rotating as the blade the kinetic energy of the wind is converted into mechanical energy. To reduce the speed of the blades, a mechanical brakes are used, and this mechanical energy is converted into electrical energy with the help of alternator, and through wires they are connected to the step up transformer. Through step up transformer the power is transmitted to the transmission line, and it reaches the nearby load. Okay, so that's what happening in an wind turbine. Okay, and coming to these wind turbine generators are basically of two types. One is horizontal type wind turbine generator, and vertical horizontal type wind turbine generator. And there's one more type which is nothing but vertical type wind turbine generator. And what should be the height of the wind turbine, and what should be the length of the blade, and these are maintained as per the design of the rating, or I mean and ratio is maintained for the height of the tower and the length of the blade based upon the rating of the plant. And what is the life we are going to get by this wind plant is 20 years we can run it. And the one more problem with these plants is we require regular maintenance. We have to regularly maintain these plants. For every 6 months we have to do the service. Is a main drawback of this plant. And coming to the principle of operation of this wind turbine generator, what is the working principle behind this? So whenever your can directly see on the diagram, whenever the wind energy touches the blade of the turbine, the air pressure is, so here we have air pressure. Okay, so air pressure is not uniform. It is lower at this point and it is higher at the outside of the blade. So whenever the wind pressure is uneven in nature, it is higher at one side and lower at another side. Automatically this uneven pressure will make our blade to rotate. Okay, how our fan rotates. So whenever this blade rotates, there are two types of speeds we need to consider. So first speed is called cut in speed, and one more speed is called as a cut out speed. So what is cut-in speed and what is cut-out speed? Cut-in speed is the minimum speed required by our wind turbine generator to start rotation. Here it will start rotation. Cut-out speed is nothing but this is the maximum speed of the wind turbine generator to stop the generation. I mean, here the blades will not rotate and generation will be stopped. So this is the point where our wind turbine starts generating the power, and this is the point where our wind turbine will not rotate. So what is the speed of this rotor shaft? Okay, this rotor shaft may rotate with 30 to 60 rotations per minute, and with the help of gearbox. Okay, so already I shown you the gearbox. With the help of gearbox we are going to increase the speed from 1000 rpm to 1800 rpm. Okay, and the rating of these plants will be either in terms of 10 kilowatts, or you can design it up to 36 megawatts also. Okay, and these plants nowadays on the coastal area they are installing in the rating of 10 megawatts. Okay, already I discussed what are the two types of plants is. One is horizontal axis wind turbine. Next one is vertical type wind turbine. So what is this logic of power generation? Okay, now let us try to see here what is the power generated by our wind turbine, which is nothing but the mechanical power is given by the formula half into rho into A into V cube multiplied with Cp. So what is meant by rho? Where rho is called as air density factor. Rho is called as air density factor, and the units of air density factor is density means per meter cube. Okay, it is nothing but kg per meter cube. And coming to the A, what is meant by A? A is called as the sweep area of our blade. A is called the sweep area of the blade. It is in terms of area is expressed in terms of meter square. So what is the next one? V cube, where V is called as the wind velocity. Okay, V is called as wind velocity. The units of velocity is meters per second. And what is meant by Cp? So Cp is nothing but the power coefficient of the turbine. Okay, so this is the power coefficient of turbine. The power coefficient of this wind turbine generator is 0.35. Okay, so now this is the mechanical power where the kinetic energy of the wind is converted into mechanical. But we don't want this mechanical power, we require the electrical power. So electrical power is equal to mechanical power multiplied with the efficiency of the gear multiplied with efficiency of the generator. So these two I can treat as the efficiency of the gearbox and generator is 0.2. Therefore here you are going to get half into rho A into V cube into Cp into efficiency of the total system is the electrical power, and this may be in terms of a megawatt or it may be in terms of kilowatt. Now let us try to do an problem based on this. Let's try to consider the radius of our blade is 40 meters. I mean the blade of the uh, wind turbine blade is of 40 meters, and the cut-in velocity of the wind turbine is 10 meters per second, and the Cp where the power coefficient is 0.4, and the air density is 1.225 kg per meter cube, and the overall efficiency of the gearbox and generator is zero point 0.9. And let's try to calculate the area is equal to pi into r square. When you do it, pi into r value is 40 square, then you are going to get 5026 meter square. Therefore the electrical power is given by the formula electrical power is equal to 0.5 into what is the rho value? Rho value is how much? 1.225 kg per meter cube. And what is the area? Area is 5026 meter square. And what is the velocity? It is nothing but cube. So 10 cube. What is Cp value? 0.4 into 0.9. When you multiply it, then the rating of this plant is 11 megawatts of power is generated by the wind turbine generator. So this is all about how to generate the wind turbine generator. Okay, I will show one video such a way that you can understand how the wind power is generated. So everyone unmute your mics. Here you can see here. Please give the response. Yeah, I think now the wind turbine generator is visible to you, right?
Uh,
Yeah, these are
it's, uh,
nothing but the rotor blades of our wind turbine generator. this is nothing but pitch control. I mean, these blades can rotate 360 degrees, and this is the hub. Okay, so this is nothing but the mechanical brake, and from here you are going to have a gearbox, and from the gearbox it is connected to an generator. Okay, to sense the wind speed, here we have an uh, sensors, I mean aviation light sensor, and at the top to indicate the turbine is there at a required height, a light is there, aviation light is there. And this is called as yaw control. I mean, the turbine can rotate 360 degrees in horizontal, and vertically also it can rotate. And the alternator cables are bought out, and here at the bottom you are going to have an step up transformer. From step up transformer we are going to generate the, we're going to transfer the power. And here this is nothing but the foundation. For every 6 months we have to maintain this one. Let's try to see the different components what we have. So this is how physically it will be there. And you can see here your blades can be 360 degrees rotatable. This is called mechanical brake. This is called the gearbox, and all these gearbox are connected to the generator. And this is nothing but pitch control. I mean, the blades can be 360 degrees controllable. And the bottom one is nothing but yaw control. This is called yaw motor, and this is nothing but yaw control. You can see the gearbox here. So the wind turbine can rotate 360 degrees, and blades also can rotate 360 degrees. So these are called blade, and this is called the rotor which rotates, and this is the rotor of our alternator. And this, what is shown here is nothing but stator of our alternator, and the EMF generated will be sent to the cable. So anemometer is an instrument used to indicate what is the speed of the wind. Depending upon the, if the anemometer speed is less than cut-in speed, it will not start. If it is in the range of cut-in speed, automatically the turbine will start rotating. So this kind of design is called wind turbine generator. That's how we are generating the power from the wind, and this how the power is generated using wind power. Okay, so hope you got an clarity that how the wind power is generated. What kind of power is the power from wind turbine generated? Electrical power or mechanical power? Electrical power or mechanical power?
Electrical
Electrical
power.
power. Why? Because we require voltage. Okay, that's how first you will get mechanical, multiply the mechanical
Electrical
with
power.
efficiency, then you will get electrical power. And units of electrical power may be in terms of kilowatts or megawatts. Okay, so what is the formula of mechanical power? Anyone?
Half rho A R to
So half rho A V cube CB. Rho is called air density. In the air we have low pressure and high pressure. That value you have to calculate. And the sweep area of the blade, how much area the blade is sweeping, and V is called wind velocity. Okay. And what is CP? CP is called as
power
Power
the
coefficient
core
coefficient.
quotient
of
of the turbine. Generally,
turbine.
these turbines will have 0.35. When you multiply all these values, then you are going to get the electrical power generated by our turbine. So this is how we understood in this class how we can generate the power by using which energy? Wind energy. Wind is a renewable or non-renewable?
Renewable.
Renewable. And
Renewable.
coming to the solar, solar is renewable or non-renewable?
Renewable.
Renewable. Okay.
Renewable.
And coming to the nuclear, renewable or non-renewable?
Non. Non-renewable.
These are what?
Non-renewable.
Non-renewable. It is available in limited quantity, right? Nuclear uranium and thorium are available in limited quantity, but solar unlimited quantity, as well as when you come to solar is unlimited, as well as wind is also unlimited. That's how we generate the power. Okay, so I don't say to you to remember all the things. So the examiner asks you explain about the wind turbine plant, you should able to draw this diagram. You should able to explain the parts, what are the different parts, and you should able to explain the parts. This is sustainable, this is renewable in nature, and this has an aerodynamic structure. It converts from mechanical to electrical. These points you have to explain. What is cut-in speed? What is cut-out speed? What is the principle behind it? What is the formula for mechanical power? And what is the formula for electrical power? You should be able to explain. Hope you got a clarity how to generate the power in the upcoming these classes by using wind energy as well as solar energy as well as using nuclear. Okay, so the upcoming classes will try to discuss about the safety devices what we need to use in our home. That's like how to use mcb and how to use rccb at your home. So at which time shall we have one more class? You say your convenient time will start the class, or shall I continue up to 1? I think it's already 2 hours we have been taken. Shall we continue or we'll take a break and we'll join at 2 o'clock? No
Yes,
response.
sir.
Yeah, timing 2 o'clock. Is it okay?
Yes, sir.
So see that
Yes, sir.
classwork is also, what is that, postponed. So you have only one lab. Okay, the next lab is a final lab. You have to complete all that lab work. And next lab, I mean, upcoming lab, you may have internal exam. Okay, and maximum we'll get only 10 hours. We have to complete all this 2 unit syllabus. Okay, so we'll meet at 2 o'clock. Is it okay?
Yes, sir.
Okay, sir.
Yeah, I will schedule the class at 2 o'clock. And CR, please inform to the remaining friends and your classmates, those are not joining the class. Okay. Say forcefully, sir has told to join the class. Okay, CR and LR.
Okay, sir.
Okay, done. Is the concept clear? Any doubt?
No, sir.
Yeah, okay, good. Thank you. We'll meet in 2 o'clock.
Okay, sir.
Okay, you can leave the meeting now.